All right, welcome in everybody. Today we're going to do something a little bit different than our normal CPM notes, and we're just going to focus on the basic skills that we need to have in order to factor. One of the tools that's going to be really effective for us is actually posted in your Schoology page right now. So if you go to Schoology, you are going to want to have open this 20 by 20 multiplication table. You're going to want to be able to access this as we go through problems because this is going to be the primary tool that we're going to use as we go on and factor. Now, other things to consider, since we are going away from the CPM notes, you are going to want a blank sheet of paper today, just so we can do a couple of problems together. Now, I don't know that we're going to tackle all of these problems together today, but what I do know is that we are going to jump down to the hardest problem first. Now, whenever we're being asked to factor, what we're being asked to do is we're basically being asked to take this area as a sum, and we're being asked to write it as a product. And really, the reality of it is there's a couple different ways you can sit there and go about it, and I'm just showing you one of those ways today. And when we get back in person, I might be changing up how I'm showing this to you, but at the end of the day, we're doing the same skill. Now, the way we're going to do this is we're going to take whatever this outside number is here, and whatever this number is at the back here, and these two numbers are going to get multiplied together. And we're also going to draw this x over here. Now, the x is going to be kind of like those diamond problems that we've seen pop up in the homework throughout the year. So 4 times negative 25, this is negative 100. And then we're going to take whatever number is in the middle here. Notice how I'm grabbing the negative with it. That's the number that's going to go on the bottom. Now, this is going to be kind of a fancier diamond problem for us. And the way we're going to attack this is we're actually going to make a little fraction over here on the side. Now, if you remember the diamond problems, hopefully you remember the idea that the two side numbers need to multiply to get to the top and add to get to the bottom. So what we're doing here is we are essentially going to be looking for two numbers that are going to multiply to give us negative 100 and that are going to add to give us negative 15. And this is where that 20 by 20 multiplication chart is going to come in handy. Now, what about these fractions on the side? We've never seen these with fractions on the side. You're correct. So what we're going to do with these fractions on the side is we're going to look at this first term over here. And notice how we're going to ignore the squared here for a second. We're just going to take whatever this first term is, and we're going to write out both of those here. So this will be 4x and 4x. Again, just ignore the square. And underneath is where we're going to put the two numbers that multiply to give us negative 100 and add to give us negative 15. This is where we're going to want to pull out our chart. So I'll pull my chart out right now, and here it is. Now again, we're looking for two numbers that multiply to give us 100. Now there's going to be a lot of different combinations on here, but we're just looking for all the combinations of 100 that we can find. So I see one combination right here. I do see another combination right here. I see another combination right here. And one thing you're going to notice the more you work with this multiplication table is that a lot of the times our answers are always going to kind of come in a little bit of an arc that goes this way. So I'm kind of just looking in that region to see if I spot any other ones, and I don't. So we'll take what we got. Now, when we're looking at this problem, again, we're looking for two numbers that are going to add to give us negative 15. Now, we know with the signs it can be a little bit complicated, but when I'm just checking these out, I see that 100 could be written as 20 times 5. So let's take those two numbers and we're going to put them on the bottom of our fractions. Now, it's our goal, before we do anything else, to make sure that our numbers work and that they multiply to give us negative 100 and that they add to give us negative 15. Up to this point, we have ignored the fact that it's negative. Now, here's what we know about negative numbers. We know that if I have two numbers being multiplied together, the only way to get a number that's negative when I multiply them is if one of the answers is negative. So, if I tried to put the negative on the 5 here, this would work for the top here, but it would not work for the bottom because negative 5 plus 20 is positive 15 and not negative 15. So, what we're going to do is we're going to try to move that negative over to the other side. If I put it on the 20, 5 times negative 20 is negative 100. 5 take away 20, or plus negative 20, is negative 15. So this one does, in fact, work. Now, the beauty in this method is that all of our hard work is really just finding those two numbers. Now, aside from that, a couple things we want to notice. This is a positive 5, so I'm going to put a plus 5 next to it. And then over here we can see this fraction. And what we're going to notice is that at least one of our fractions is almost always going to be able to be reduced here. So 4 and 20, 4 goes into 4 once, and 4 goes into 20 5 times, so I can reduce that fraction and make it into 1x over a negative 5. Now, to finish this, remember we want to write our answer as a product. So we're going to grab our parentheses here, and our answer is actually going to be these two side fractions. So our first answer is going to be 4x plus 5, and our second one is going to be 1x minus 5. And what we've just done, whether we realize it or not, is we've factored this. Now, if you remember factoring and the generic rectangle, one of the big ideas was that if we took this area as a product, what that would do is that would outline the different parts of this rectangle. So as we're looking at this one, if I had the 4x here, and then the positive 5 over there, and the 1x here, and the negative 5 over here, if we were to just multiply these out, what we would see is that we do have the same area as what we started with. 1x times 4x, remember that's going to be 4x squared. 1x times 5 is going to give us 5x. Negative 5 times 4x is going to give us negative 20x. And then last but not least, if I take negative 5 times positive 5, this gives us negative 25. And then the last part to realize about this is that if I were to pull these terms out, we see that we have the 4x squared, which is the same thing, that I am noticing between here and here. I do have the minus 25, which is the same thing I'm going to have over here. And then if I take those two middle terms, remember those are our like terms, so we can add those together, that does give us negative 15x. So what we have done by using this method, and I know it was a little quirky when we did it, is we have in fact found a way to factor it, and this would essentially be what our answer is. Now, this method does take a little bit of practice, so that's what we're going to be focused on today. So here's another problem for us to tackle. Let's see if we can remember the steps on our own without looking back too much. Remember, the first part is to set up your x. Once you set up your x, maybe draw a little multiplication symbol here and a little plus symbol there. On the side, you're going to draw your fractions. Now it's time to get the numbers in play. So to get the top number, you're going to take the two outside numbers and you're going to multiply them together. So 2 times 5 is going to give us a positive 10. Whatever the middle number is here, the one that has just an x with it, that's going to become the number on the bottom. So I need to think of two numbers. Well, before we do that actually, what's going to go on top of the fraction? Now hopefully you remember, what goes on top of the fraction is what we see right here, but we pretend that the squared is not there. So we're going to put a 2x on top and a 2x on the bottom. Now we're just looking for two numbers that multiply to be 10 that add to give us 11. Now maybe you're good at coming up with these numbers right away, or maybe you're not. So I'm going to go back to my multiplication table for a second. Since I'm looking for numbers that multiply to give us 10, I want to circle all of the 10s that are on my multiplication table. I think I got them. Again, notice how they follow kind of that arc. And these are just all the combinations of numbers that multiply to give us 10. So remember, we were looking for two numbers that multiplied to give us 10 that add to give us 11. So for this one, it would have been 10 and 1, and notice those do add to give us 11. So on the side over here, I can put a positive 10 here and a positive 1 there. And on this one, we do always want to double check to make sure it works. Does 10 multiplied by 1 give us 10? And the answer is yes. And 10 plus 1, does that give us 11? And the answer is yes. So really, when we're doing this, we just have to get really good at organizing our thoughts. Now, since that's a positive 10 and a positive 1, we're going to put a little plus sign next to them. And then here's the last step. The last step involves looking at those fractions. And remember, one of those fractions is always going to be able to be reduced. So if I look at this fraction right here, 2 goes into 2 once, and 2 goes into 10 5 times. So that fraction could be reduced. At this point, I can draw my parentheses, and I can grab my factors. So my first factor will be 1x plus 5. And my second factor is going to be 2x plus 1. And just like that, we have went through and we have factored this trinomial up above. And again, factoring just becomes a really, really big skill for us in math and one that we're going to have to use frequently. So we want to get good at this. Let's take a look at another problem. So here's another problem. First thing we're going to do is we're going to set up the x. Once we set up the x, we'll put a fraction on each side. I like to draw a little multiplication symbol and a plus symbol. Once we do that, we can add in a few more pieces. So we know that 5 times 12 is what's going to give us our top number. 5 times 12 gives us 60. Our bottom number is going to be the number that's right here. Remember, it's really important to grab the sign that's in front of it. So this would be a positive 19. On top of our fractions, we know that this will be 5x and 5x. Now, the bottom part of our fraction is the only part that we actually need to figure out. And the easiest way I find to figure this out, if I can't just tell right away, I like to go to my multiplication table. So the number I'm trying to multiply is 60. So that's the number I want to find on my table. So as I'm looking across my table, I'm looking for 60. Oh, I see one here. I see another one here. I see another one here. Oh, lots of 60s on this one. There's another 60. There's another 60. Another 60. And do we have any others? There's another. Oh, there's another even too. Now remember what I told you. These always kind of go on a little bit of an arc like this. So look for them. Once you find one, hopefully you can locate the others. Now we just need to find which combination of numbers is going to add to give us 19. Well, 60, both of those are positive, so that's important, right? This was a positive 60 because it was a positive 5 and a positive 12. And this is a positive 19. Now, since everything's positive, we know our numbers need to be positive. So as I'm looking at this, we're looking for two of them that are going to add to give us 19. Well, this one would be 20 and 3. And 20 and 3 don't add to give us 19. So not this one. This one is 15 and 4. And hey, wait a second. Last time I checked, 15 and 4 both add to give us 19. So those must be our numbers. So I'm going to take one of the numbers, and it doesn't matter the order here. I'm going to put 15 over here and 4 over here. And since those are both positive, I'm going to put a plus on both of those right now. Now, as soon as I've done that, then what I want to do is I want to look at this and I want to say which fraction is going to reduce. Remember, most of the time, one fraction will reduce. So as I'm looking at this, 5 and 15, this would become 5 goes into 5 once and 5 goes into 15 3 times. And if I look at this other one, this one doesn't reduce at all. There's no number that goes into 5 and 4. So my factors for this are going to be 1x plus 3 and then 5x plus 4. And the reason those are pluses is because our numbers were positive. Nice job. Let's go to another one. So let's skip back. I think this is hopefully going okay for you. Let's get to some easier problems maybe. We're kind of working backwards towards easier ones. We started with the hardest today. So on this one, we're going to start by making our x. I'm going to put my multiplication symbol in so I don't forget, and my plus. I'm going to have my fraction and my fraction. Now, 2 times a negative 9 is going to give us a negative 18 on top. The negatives get a little tricky, so we want to be careful with those. On the bottom, we're going to take whatever this middle number is. So 3 is going to go on the bottom here. Now, on top of the fractions, remember, we take whatever this is and disregard the fact that that 2 is there. So this would be 2x over and 2x over. Now, what we're doing is we're looking for two numbers that multiply to give us negative 18 that add to give us 3. So I'm going to go back to my table again. Now, since the multiply number is negative here, I'm just going to look for positive 18s because there's no negatives on my chart here. And we're going to adjust accordingly after that. So I see an 18 down here. I see another 18 here, another 18 here, another 18 here, another 18 here, and another 18 over here. So let's figure out which one has the right combination to add to 3, right? Since 3 was our number on the bottom. Now, when I'm doing this, I can guess check all of these if I wanted to. For this first one, this would be like 18 and 1. And those numbers are pretty far apart, so I'm pretty sure I can't get to 3. This one is 2 and 9, and I'm pretty sure those are too far apart as well. This one kind of interests me, though. So this one right here is 6 and 3, and those are about 3 apart, and 3 was the number I was looking for, so let's see if we can make those work. So 6 and 3. So I'm going to go back to my problem. I'm going to put a 6 here, and a 3 here. Now, it's possible those aren't our numbers and that we kind of jumped the gun too early. And if that's the case, then we could just erase them and keep looking. Now, remember, in order for two numbers to multiply to give us a negative number, one of those numbers has to be negative. So I'm going to try putting the negative on the 3. And if I do that, 6 times negative 3, that is negative 18. And 6 take away 3, hey, that is 3 as well. So we did find the two numbers. That's great. We're almost done. Remember, this would be a positive 6, so I am going to put a plus 6 in there. And the last part we just need to look for is we need to look to make sure one of our fractions doesn't reduce. Well, 2 and 3, we know those don't reduce, but 2 and 6 do. So what number goes into 2 and 6? And hopefully you can say 2. 2 goes into 2 once, and 2 goes into 6 3 times. So I can reduce that fraction, and then my final expression will end up being 1x plus 3 and 2x minus 3. And just like that, what we have done is we've went through and factored. Great job. Like I said, I promised we were getting towards easier problems, and here we go. Now this is officially an easier problem. And one thing you're going to notice about this problem is that we were used to looking at problems where there was a number here. And this one doesn't really have a number there. Or does it? Don't forget, you can always put a 1 in front on these problems to sit there and show that you know that that's there. And at that point, we can just continue on the same way we did. So we'd put our multiplication sign, our addition sign, we'd make our fractions. 1 times negative 10, again, notice I said negative 10 there because the negative was in front of it, will give me a negative 10 on top, and then whatever the middle number is, that's the number I put on the bottom. Now, again, to get your side numbers, the top ones here, that's looking from this term. You look at this term and you pretend the 2 wasn't there and you copy that down. So in this case, it will be 1x and 1x. Now let's try to do this one without needing to use our multiplication table, but we can always go back to it if we need it. So we're looking for two numbers that multiply to give us a negative 10, that add to give us 3. Now the first thing that comes to my mind is maybe like a 5 and a 2. And right now, of course, they don't work because a positive 5 and a positive 2 would make a positive 10. So I'm going to try to put the negative on the 5. And when I do that, what I find out is that the top now works, but the bottom, negative 5 plus 2, does not. Negative 5 plus 2 would be a negative 3. So that did not work. So maybe what I'm going to do is I'm going to try to move the negative over onto the 2. So again, the top would now work, and then 5 plus negative 2, that's the same thing as saying 5 take away 2 is 3, and we found our numbers that worked. Now again, this is a positive 5, so I am going to put a plus by it. Now one thing that's unique about this problem is notice 1 and 5, there's no number that goes into both of them other than 1, and 1 and negative 2, same story. So in this situation, neither one of those fractions reduces. So when this happens, we're just going to take whatever the first one was. So the first one, 1x plus 5. And then we're going to take whatever the second one is, 1x minus 2, and we'll write them the exact way we see them. Now it's really important that we always look to make sure those can't be simplified or reduced. That's a really big part of making sure our answers get correct. Let's try to do another one. How about this one over here? So copy this one down onto your paper. Remember there's a 1 in front here. So when I set up my x, I'm going to have a multiplication sign and a plus sign. I'm going to have my fractions. I know I'm going to have 1x on top of the fractions. And then to get my top number, I'm going to take 1 times positive 30, and that's going to give me a positive 30. And then I'm going to take whatever this middle number is. This one is a positive 13, and I'm going to put that down here. Now we just need two numbers that multiply to give us 30, that add to give us 13. Wonder if any of you can figure out those two numbers. Hopefully, you can realize that that is a 10 and a 3, and both of those would have to be positive. Now, once we've done that, notice something else for a second. Again, we have a situation where our fractions don't reduce. And since that happens, then we take our factors the way they're written. So for our first one, this would be 1x plus 10 and 1x plus 3. And we just want to copy those the way we see them, and we're done. And we factored. Nice job. Now, let's do this. Let's have you guys try this problem on your own right now. I'll pause the video or you should pause the video for a second and see what you can do on it. All right, welcome back. Hopefully you were able to come up with a solution. Here's how I would have solved it. I would have started by making my x. I would have made the fraction on the side of the x's. I would have had a multiplication sign up top. I would have had an addition sign on the bottom. Remember, this is 1x, so I'm going to put a 1x on top and a 1x on top. Now, 1x times a negative 24 gives us negative 24 on top. And then I'm going to have a positive 2 on the bottom. So we're looking for two numbers that multiply to give us negative 24 that add to give us a positive 2. Now, for me, nothing's coming to mind right now. So what I'm going to do is I'm going to go grab my multiplication chart. This is one you're going to want to have pulled up as you work through your problems today. So we're looking for numbers that multiply to give us 24. Again, we can just disregard the negative. So I spotted one right here. Here's another one. Here's another one. Do I see any other ones? Remember, I'm following that little bit of an arc. Looks like we got all the options. Nice job. So now let's see if we can find two of them that would be able to add to 2. So the first one is 12 and 2. And I know one of them is going to have to be negative because my top number is negative, but I don't think those are going to be the two for me. So I'm going to leave those for now. I'm not going to cross them out completely, but I might say I don't know that they're going to be helpful. So another combination is 8 and 3. And again, I don't think I'm going to be able to make that work. You can play around with it and test it out if you would like. But then I do see this other 24 right here. And this one is a 6 and a 4. So let's play with the 6 and the 4. So if I put a 6 here and a 4 here. Now we know one of them needs to be negative. So I'm going to try to put the negative on the 4 this time. And when I do that, notice what happened. 6 times negative 4 equals negative 24. 6 plus negative 4 is equal to a positive 2. And just like that, we found a way to factor these things. So for my final answer here, I'm going to have 1x plus 6, right, because this was positive. Now again, this fraction did not reduce for us, so we were good. And this one over here also does not reduce, so we know we're at our final answer. Now the last part I want to mention today is why don't those fractions reduce? At the beginning, all of our problems started with reducing fractions, and then all of a sudden they stopped. And I'm wondering if you notice why that was. Now, the reason's actually kind of simple. The problems in which it didn't reduce were the ones where it was just 1x squared. So 1x squared, 1x squared, 1x squared. These were the ones it didn't reduce on. But anything that was more than 1x squared, we can expect to reduce. So let's do this last problem together, and we'll call it a day at that point. So we'll make our x. Up on top of our x, I'm going to put my multiplication symbol. On the bottom, I put my plus. Then I make my fractions. Now on the side, I'm going to have 3x and 3x. Now, since this one already has a number, I think I'm going to have to reduce my fractions at the end. But we always just want to look for that reduction so we don't forget it. So 3 times negative 5 is negative 15. And we'll have a negative 2 on the bottom. So now we're just looking for two numbers that multiply to give us negative 15, that add to give us a negative 2. When I think about 15, the only numbers I think that multiply to be 15 are 5 and 3. So let's see if we can make those work. Now if I put the negative on the 3, 5 times negative 3 would work for the top, but 5 take away 3 would be a positive 2 and not a negative 2. So that didn't work. So let's try to take that negative and move it over to the 5. And if I move it over to the 5 now, what I see, negative 5 times 3 is equal to negative 15. Negative 5 plus 3 is actually equal to negative 2. So as soon as you find those numbers that work, you're about done. Now remember, our answer at the very end of the day is that area as a product. So we need the parentheses, and then we're going to have 3x minus 5. This was not the fraction that reduced, but this fraction over here will reduce. Remember, this is a plus 3. 3 goes into 3 once, and 3 goes into 3 once. So this will be 1x plus 1, making this our final answer. Thank you guys so much for watching today. What you guys are going to go do now is in your homework packet on 8.1.2, you're going to be going through and you're going to be doing problems 17, 20, 21, and 22. Thank you so much for watching. Have a great day.